Okay, so today we're going to go ahead and go over how to use Avogadro's number. Remember, we brought this concept up, we brought the concept up to the mole, but we still haven't really used it besides finding molar mass. Okay, so first the question that we're going to try to answer is, when do we use Avogadro's number? Okay, so whenever we have a conversion in which we're going from moles to atoms, or from moles to particles, or moles to molecules, we're going to go ahead and use Avogadro's number. Or the other way around, whenever we go from one of these to moles, we want to go ahead and use Avogadro's number. Okay, so just kind of to refresh, 1 mole, we know 1 mole equals 6.02 times 10 to the 23 of whatever we're talking about. So 1 mole equals this amount of atoms or this amount of particles. It doesn't matter what we're talking about, because 1 mole is kind of like a dozen, right? You can have a dozen eggs, that means you have 12 eggs. Or you can have a dozen shoes, that just means you have 12 shoes. So it's just a unit that means this amount, and it could be any of these. Okay, so let's go ahead and see how we're going to use this for today's problems. Okay, so the first problem we have here, it says, how many atoms are in 4 moles of nitrogen? Okay, so for these problems, you actually don't even need to use a periodic table, because I know that in this conversion, we are going from moles into atoms. Okay, so my equivalent, I already know that because I already set that up, right? I know that 1 mole equals 6.02 times 10 to the 23 atoms, right? So that's already, I have my conversion already. That's going to stay the same. Okay, the only difference is there would be 1 mole of nitrogen, because that's what I'm talking about. So I go ahead, I list what I'm starting with. So I go 4 moles of nitrogen, right? Times same thing we've been doing. Okay, before we do this conversion, I want you to think about this problem as well. So if 1 mole of nitrogen equals this many, then 4 moles would just be 4 times that much, right? So it's just going to be, our answer is going to be multiplied times 4. And we'll see why. It'll be basically 4 times Avogadro's number, right? So taking my equivalent, taking this that I have here, right? So moles are going to go in the bottom, and then Avogadro's number would go on top, because that's what we want. So I go 1 mole of nitrogen in the bottom, because I start with that, so I got to cancel out. And then Avogadro's number on the top. So 6.02 times 10 to the 23rd atoms. Okay. Then you want to go ahead and do that math on a calculator. You do need a scientific calculator. Okay, so the biggest part where people mess up is, how do we put this number in? So every calculator is different. For this calculator, I put it using this symbol here. So I would go 4 times 6.02 times 10, and then I can put to the 23rd by putting that little symbol there. Okay, on yours you might see that little caret symbol. If you put that, that will allow you to put it to whatever power you want to put it to. So to 23rd, and then go ahead and close this bracket here. Okay, enter, and that's going to go ahead and give you my answer. Some calculators might read it differently. I'll show you guys examples later in class, but that's going to be our answer here. Okay, so our answer is going to go ahead and be, we'll just go ahead and round to that first decimal. So it'll be 2.4 times 10 to the 24. Our units are canceled out. Cancel. I'm left with atoms. Okay? Atoms of nitrogen. All right. So let's go ahead and go on to the next one. Very similar, but now we're converting 3.5 moles into molecules. Okay, it doesn't matter for dealing with molecules or atoms. It's the same thing, because 1 mole always equals this amount of whatever we're talking about. Okay, so in this conversion, we're just going from molecules. We're going from moles, and we're converting into molecules. Okay, into molecules. So we're going from moles to molecules. Okay. So I know that 1 mole always equals 6.02 times 10 to the 23rd molecules. So I go ahead and I set that up. I have 3.4 molecules of NaCl, so molecules of NaCl, right, times, well, my conversion is just the same thing here, right? 1 mole of, and I can put it on the side here if that confuses you. I'm basically saying that 1 mole of NaCl equals Avogadro's number, right? 6.02 times 10 to the 23rd times 10 to the 23rd molecules. So that's where I'm getting these numbers from. So I'm starting with, sorry, this should actually be moles here. So I'm starting with 3.4 moles of NaCl. So that moles are going to go in the bottom, similar to this we did up here, right? 1 mole of NaCl goes in the bottom. I'm just basically taking this, putting it down here. And then on the top, I'm just going to go ahead and put molecules on top because that's what I want. So 6.02 times 10 to the 23rd. Fit that in there, molecules. Okay. I go ahead, moles of NaCl cancel out, and I'm just left with 3.4 times Avogadro's number. Okay. So that's going to give me 3.4 times 6.02 times 10 to the 23rd, close it, close the brackets there, enter, okay? And that's going to be my answer. So my answer will be 2.0. I can just leave it like that because I rounded to that first decimal, right? That was a 4, so that'll stay at 0, times 10 to the 24 molecules of NaCl. Okay, so what this means is if I were to have 3.4 moles of this, for example, in a container, I would have 2 times 10 to the 24 molecules of NaCl. So that's a lot. That's basically 2 following 24 zeros. Okay, all right, let's go ahead and go to the last 2 problems. Very similar, however, it's just the opposite. Now we're going from atoms into moles. Okay, so our question is, how many moles are in 2.6 times 10 to the 24 atoms of carbon? Okay, so again, it doesn't matter what we're dealing with. Whenever we're going from moles to atoms, we don't even need to use a periodic table because I always know that 1 mole of whatever we're dealing with, in this case carbon, will equal Avogadro's number. Okay, so it would equal that many atoms. Okay, so let's go ahead and do this problem here. So I'm going to kind of write it out for you. So I have 2.6 times 10 to the 24, times 10 to the 24 atoms of carbon. Okay? Atoms of, I should start, let me write atoms here. That's my starting unit. Atoms of carbon. I'm going to go ahead and multiply this times this, so conversion fraction. So what goes on the bottom now is Avogadro's number, right? Because I want to figure out how many moles I have. So I go 6.02, Avogadro's number in the bottom here, atoms of carbon equal, this many atoms of carbon equal 1 mole, because the top and bottom are always equal to each other. Okay? Then we go ahead and this cancels out, and we're left with our answers in moles. Okay? So this is where people tend to get confused on how to do this math. Basically, what you're doing here is you're taking this number and you're dividing it by this bottom number here. Okay? In other words, what you're doing is, let me show you how to put it in the calculator because that's kind of where the mistakes tend to come in. So it would be 2.6 times 10 to the 24, close my bracket, actually put this light on, and then I'm going to go ahead and click enter for my, and it's going to save it for me, right? So now it's saved in my calculator. So now I'm going to divide, but when I divide, this is a really important part, I want to put my whole answer in brackets, because if I don't, then what my calculator and what most calculators tend to do is it's going to divide by this and then multiply by that if you don't put it in brackets. So what you need to do is you need to put this whole thing in like parentheses here, okay? So we go times, my parentheses, 6.02 times 10 to the 23rd, and then close those parentheses, enter. That should give me my answer, okay? So my answer is 4.3, we'll leave it like that, 4.3 moles, okay? So this here would equal 4.3 moles of carbon, okay? And that process just continues, okay? And again, it does not matter if it's atoms or molecules. So let's look at an example here in which we're going to do the same thing. So I have 8.3 times 10 to the 23 atoms, or rather in this case molecules of H2O. I want to convert this, this should be how many molecules are, actually let me fix this problem quickly. It should be how many moles are in this many molecules of H2O. I'll try to have that fixed for you on your worksheet there. Okay, so we're trying to figure out how many moles are in 6.3 times 10 to the 23rd molecules of H2O. Well, so this is what I'm starting with, right? And I'm just going to go ahead and do the same thing that I did up here. So times, the only difference is that I'm not going atoms of carbon, I'm going molecules of H2O. So I go Avogadro's number, right? And the reason I'm doing Avogadro's number is because let's look at our units. If I start with molecules here, then I need to have molecules of H2O down here. And what I want is moles of H2O, okay? So what I'm going to have here is going to be, well, molecules of H2O. If I look at this, if I look at my conversion, that's going to be Avogadro's number, right? So I go 1 mole of H2O equals Avogadro's number. And then I just go ahead and do the math. Cancels. This times 1 divided by this whole thing. Okay? So I'm going to go ahead and put that in the calculator here. 8.3 times 10 to the 23rd. I'm going to click enter on my calculator, save it. Your calculator might be different. Now my answer is saved. And I'm going to go ahead and click divide. Put some brackets. 6.02 times 10 to the 23rd. Close the brackets. Enter. My answer is 1.37. I'm going to round that up because I'm rounding to the first decimal for all my problems. That's going to give me 1. This would equal, put it down here, 1.4 moles. 1.4. My only units left over are H2O. 1.4 moles of H2O would be my final answer. Okay. Now, kind of just leave this here. If you guys want to take a look at it.